Good day, everyone, and welcome to the second webinar associated with Biodesign Challenge and Open Fung's MycoStack Micro Challenge. It is a pleasure to have you with us today. For the month of August, our organizations are soliciting protocol submissions from the global community of researchers, artists, educators, and mycelium enthusiasts to develop an open access educational resource for anyone interested in learning more about mycology and mycomaterials. This collaboration reflects our organization's shared mission to support the next wave of innovation in functional mycomaterials through the democratization of science. Next week, we will host our final webinar, Growing the Field, a conversation on the future of mycelium education with Dr. Callie Rogers Chappell, Antoni Gandia, and Denise Middleton. It will take place on Tuesday, August 25th at 2 p.m. EST, Universal Time Zone -4, and will be facilitated by the Open Fung team. Today's webinar, Surf and Turf, Designing Fungi Solutions for the Blue Economy, is held with Amelia Martin. Amelia Martin is the CEO and solo founder of Mudrat, a biomaterials company creating eco-friendly alternatives to high-performance foams in the marine and action sports industries. Martin is a surfer and a surfboard shaper with an MS in plant science from the University of Connecticut. She is passionate about the blue economy, circular materials, and waste management. Today's webinar will last for roughly 40 minutes, followed by a brief Q&A period. Over the course of the presentation, we invite you to submit your questions to our speaker using the designated Q&A box at the bottom of your Zoom screen. Lastly, I wish to direct your attention to the Zoom chat, where in a few minutes we will post outbound links to our competition and organizational pages. We are presently 3/4 of the way through the MycoStack Micro Challenge submission period, and we would love to get you all involved. Remember, participation costs nothing, and there are multiple forms of recognition for all your contributions to open access mycology. Thank you all once again for joining us today. I will now turn the Zoom room over to Amelia Martin for Surf and Turf, Designing Fungi Solutions for the Blue Economy. Thank you so much, Amelia.
Thank you for having me. All right, let's see if I can do this the right way. Mm, Hmm. Oh, I'll be back in 1 second. I need to restart it.
While Amelia is restarting, I will add the links to the competition page, Open Fung's website, and the Biodesign Challenge website in our chat.
Okay, I'm back. Let me share my screen. Awesome. All right, sorry about that. I just had to re-download Zoom, but we're good now. So, hello. Thank you so much, Paul, for the introduction. I am so excited to be giving this talk with you guys today on how to use mycelium solutions to create the stepping stones for new materials in the ocean and maritime field, something that I'm very passionate about. And I'm super excited to be able to share this with you guys today. So I know that you just got a little bit about myself, and I'll give you a little bit more about myself. So, hello again. My name is Amelia, and I'm born and raised in Connecticut, which is an unfortunate fact because I love the ocean. I love surfing, making surfboards, all things associated with that. I've been in Connecticut my whole life. I got my degree in environmental studies from the University of Connecticut in 2023. And I recently graduated with a master's in plant health, plant science in 2025. And that was on more so plant pathology. So completely unrelated to mycology, actually. I did a lot of work on disease and diagnostics, but I did learn a lot of useful lab techniques. So, like I said, my interests love the ocean, of course. And I'm also very interested in waste management and plastic pollution and marine debris. So I'm going to start by really emphasizing I have had no formal training or education in mycology, design, or engineering. Everything that I have learned while building my company has been from YouTube videos in my apartments, has been just learning everything myself hands-on. And that's why you guys should totally submit some protocols for the Biodesign Challenge and Open Fungs project that they have going on, the MycoStack project, because if I had these resources, maybe I could have saved myself a year of research in getting all this off the ground and going. But with that, I just want to say this isn't going to be a highly technical conversation that we're having today. Feel free to ask technical questions. I'll do my very best to answer them. And yeah, I hope that this is more just a inspirational, just something to open your mind up a bit more. And before we get into everything, I love to have a definitions page just right at the beginning for anyone who maybe this is your first mycelium webinar that you've been to, or maybe you don't know what a surfboard blank is, because a lot of people don't. So anytime you see the word blue mentioned, that's just interchangeable for meaning the ocean or affiliated with the oceans and the marine space. Mycelium, we're going to go with the basic definition. So it is the root-like structure of fungi, and it encapsulates every species and all species of fungi. And surfboard blank, that just means the inside of a surfboard. Surfboards are made out of styrofoam, fiberglass, and resin. We're talking about that styrofoam chunk on the inside. And then EPS, PU, and PS are all the technical terms for what styrofoam is. So it's expanded polystyrene, polyurethane, and regular polystyrene. You guys are going to learn so much today. Maybe not just on mycelium, I hope. But like I said, the goals of this seminar, I really hope that some of you get inspired to try some new ideas and new methods for how to make mycelium products, and also to just get a better glimpse of what we can do specifically in the marine space. So let's jump right into it. And we're going to start on a bit of a bleak note, but I think it's good to get a glimpse of the problem and why finding solutions specifically in mycelium for the oceans is so important in this day and age. So, in case you don't know, 2016 came out with a famous statistic from the Ellen MacArthur Foundation that by 2050 there will be more plastic in the oceans than fish. So, unfortunately, we are still moving in that direction. Not much has changed. If anything, plastic is being produced at a much faster rate now than it was before. So, it's very unfortunate, but it's even more imperative that we figure out these solutions sooner rather than later. And a big part of the statistic is what some of you guys may be familiar with, which is the Great Pacific Garbage Patch. So this is a gigantic chunk, which back in 2015, when this, let's say graph, when this graph was created, it was twice the size of Texas. It has grown exponentially since that point. And there are some great organizations like the Ocean Cleanup, which have removed tons and tons of plastic from this patch. However, the rate at which it's growing is still too much for any real damage to be caused by the organizations. This thing is just taking over. It's mostly made up of microplastics, which are plastics that are, I believe, don't quote me on this, between 2 and 0.5 millimeters in length. So very tiny little pieces of plastic. And this patch can't even be seen from a satellite. It's very thin. It's like this big, thin sheet on the surface of the ocean. But it leaches chemicals. It's does mass destruction to wildlife, as you can imagine. Plastic, this patch, horrible. And there is actually a second patch too in the Atlantic Ocean, but the Pacific ones really are big. That's our big guy. So when we think about the plastic in the ocean, a lot of times maybe you're thinking about a plastic cup that got diverted from a landfill, found its way to a waterway, and has now made its way into the ocean. That is those single-use plastics are a major part of the problem, but the materials that we're directly putting in our oceans also play a major problem. So there's an example of styrofoam buoys and an example of plastic fishing gear. And think about anything and everything that you're putting in the ocean that's coming into contact with the ocean. We're talking buoys, boats, wave breakers, dive gear, aquaculture, so oysters and lobster farming. All of that material has plastic in its manufacturing chain at some point, with the exceptions of a few, like if we're thinking a wooden surfboard, which is the top tier, most sustainable, but that's expensive and it's pretty difficult to get one of those. So everything that we're putting in the ocean is made out of these harmful materials. And there's not, like I said, a lot of solutions for it. But today I get to bring back my favorite photo of all time. I love this photo. This child pointing with a sad look on his face at a chunk of styrofoam. So today we're talking about styrofoam in the ocean and how mycelium can alleviate that. So if anyone is familiar, one of the big when people think of mycelium products, a lot of people may think of furniture, they may think of the vegan leather or the bacon, but styrofoam packaging alternatives was really one of the big kickoffs in mycelium and with what mycelium could do. So, before I teach you guys a little on how to think about mycelium for these applications, I'm going to give you a quick origin story. And this origin story may be very similar to some of your guys' stories. Hopefully you'll have a quicker knowledge intake with the help of this awesome program that's going on. But quick origin story. So I'm a surfer. I make surfboards. That was explained in the beginning. Like I also said in the beginning, surfboards are made out of styrofoam. You can see that one in the back. This is one of the best photos I've ever taken. I just want to point that out too. But I took this in the middle of me working with these surfboards. So see all of that white dust that's stuck to me? That's what happens if you're sanding away at styrofoam. Styrofoam's so light, it's very static and it sticks to everything. So I was making surfboards in my garage, wearing the full protective gear that you see there, and I was breathing it in still, even after I cleaned myself off. I was getting a rash, I was getting a cough. I looked it up. Styrofoam's a carcinogen, horrible for human health. Looked it up further and just like, oh, I bet this is bad for the environment too. Boy, is it. It's horrible. So horrible for the environment, horrible for me. I tried to look for a different material to make my surfboards out of, and this was back in 2019, I believe. So I was looking for a different material and there was nothing because the materials that you put in the ocean have a whole different criteria than materials that you'd be using on land. So there weren't any solutions for the inside of surfboards at the time. And I couldn't continue doing this work knowing the damage that I was causing to myself and the environment. So I applied for a grant at my university, UConn, and I worked with an industrial arts professor because I was like, listen, there's no biomaterial because I'm gonna make an alternative to styrofoam for surfboards. That's what I want to do. But I can't find any different alternative material to use that isn't super expensive, that I don't need to import it, I don't need some type of machinery. And he told me, oh, one of my students just made a sculpture out of mycelium. It was like $20. You can get a bag online. Like you should try it. So I tried it. The cheapest option, literally the only thing I could afford, was working with it in my kitchen. And it worked well enough that I was like, okay, I bet if I keep working on this, something good can come from it. And that was it. That's the origin story. So very bare bones, very I'm doing this for really cheap out of my apartment. And it's what a lot of you guys may also have, how you guys have started as well. So it's a classic tale as old as time. But let me tell you where this has gone now since the surfboards and with the surfboards. So if you were thinking like I was back in 2019, like, oh, there must be there must be a better solution for styrofoam out there in the surf industry, which is so focused on sustainability, and in the broader marine industry in general. And you'd be correct in thinking that they care about sustainability because it is huge for them. They are the industries that directly rely on having a healthy environment, but there's nothing and there wasn't anything there. And these are just a couple examples of, I would say, the movements or the organizations. These are a couple organizations in the blue economy that focus on voluntary sustainability certifications. So, EcoBoard, they've been around since, I would say, 2014. Rough guess, don't quote me. But they've been around since 2014, and they will certify you as a board maker. They certify materials based on the level of sustainability that the materials are created with. So you could have like recycled foam, maybe that would be a tier one. You could have wood, maybe that's a tier two. And it's really just a big push, like an extra certification on, oh, I'm a surfboard shaper. This looks better for me. It's a better marketing if I say that I use sustainable materials and my customers want that. So that's EcoBoard. And then Green Marine, it's essentially the same thing, voluntary certification, but for the shipping industry. So they track metrics such as fuel usage, like what boats are doing with their waste. And one of the things that they would want to track is the materials that the ships are actually made with. But since there's such a lack of those materials, that hasn't been able to make its way into those certifications yet. So they care. That's the bottom line. They care heavily. And before we get into why the surfboard as is for mycelium didn't work so well, I want to tell you about someone who does do mycelium surfboards. To say they aren't all failures, essentially. But Co's surfboards, they're out of France. They're the only company right now making end product mycelium surfboards. And keep in mind, I say end product. So they aren't making the internal cores like we are doing. They are making the whole surfboard from start to finish using the standard technique, which we're going to go over later. But they're allowed to do that with the standard technique because they have control over how they're putting the resin on. And I'm getting ahead of myself. Let me tell you why it didn't work. But basically, Co's, they're awesome. You can look them up. So let me get into what I was just babbling about. So the mycelium surfboard is a common thought, I would say, at this point. These are just a few examples. Like we've made our surfboard. Steve Davies out of the UK, he was a design student, has since graduated and he did not continue the project, but he's a cool guy. He's awesome. And then we have Ecovative, who worked in collaboration with a surfboard shaper out of San Diego. And they were actually the first combo that made the mycelium surfboard. And this was in 2015, I believe, that they did it. And if you notice something across all of these photos, all of the surfboards in these look the same. They all have that standard that you would see if you looked at a chair. There's a photo of a chair in this presentation, and it haunts me. But they all have that same like kind of wood-ish look. Maybe there's that white mycelium covering on parts of the board, but they all look the same. A lot of you who have experience in working with mycelium can probably look at this and be like, I know exactly how you made that, and you're probably right. This is how it was done. This is one of the only infographics I could really find that give a decent step-by-step of the standard technique. It's from reddirtmushrooms.com, and I just crossed out that little bottom part right there because how you're going to make a mycelium material or a mycelium product is essentially the same starting steps that you would if you were going to farm tabletop mushrooms. So what you're going to do, and this is just the nice step by step, is you're going to either acquire grain spawn, which is it's basically bird seed, which has been mixed or inoculated with liquid mushroom spores. And then the mushroom spores eat that, and you have this nice white chunk of grain spawn. And then what you're going to do is you're going to mix it with substrate otherwise known as feedstock. And this is what the mushroom's going to eat and decompose, get nutrients from, so that can grow and it makes this nice white block. And you're going to mix it, put it in whatever mold you want to grow in, let it grow in that mold because it will basically fill out the shape of that mold really nicely. And then at that point, if you're doing this on your kitchen top and you want to eat some mushrooms, you can cut your bag open, you can remove the lid, and a mushroom would pop out. But if you want to make a material, instead of cutting that, you're going to take it out of the mold, bake it literally in an oven, low temperature, for I'd say like 2 hours. This is just back of my head recipe, but pop it out. The water had been removed at that point. You basically stop the mushroom from growing, and that's how you make your mushroom product. So that's the standard. If you look up anything on YouTube, if you're first starting out in mycelium, that is the step by step that you're going to get. And that's not great for ocean stuff. And I'm going to get into why that is. But excellent for a sculpture, excellent for furniture, a bit different for leather and bacon and all that. But if you're starting, that's what I did to start. That's how I learned from doing this. And it's a great technique, but it needs to be refined before you can put these things in the ocean. So, me and Steve and Ecovative all did the same thing. We all did the starting technique. And there have been tons of other people who've also made surfboards using this starting technique. And I've been on the phone with a few of them, usually students from universities doing a thesis, and they're like, it's not working, it doesn't work. And I'll be like, let me guess, you're having this problem and this problem. And they're like, yeah. I'm like, yeah, that's because we did it this way. So, I think that a surfboard's the best way to think about mycelium in ocean uses. Maybe I'm biased, but with a surfboard, starting off the bat with mycelium, we need to consider different things for if this is getting put into a harsh environment like the ocean versus if we're going to keep this as a sculpture. So mycelium off the bat is roughly 5 times heavier than styrofoam. And I'm talking about mycelium once it's mixed with substrate, like your final product, not as is, because I believe it's actually less dense, but don't quote me on that either. So it's heavier than styrofoam, which is not good for the ocean because we need it to be buoyant and we need everything to be able to float really nicely. So that already isn't good. If you remove the first layer of mycelium off of your material, imagine you have a block and you rip off that first layer of flesh, I'll say, then it reveals all of these air pockets, which is right here. And it works pretty good with machinery. So as you see here, we are able to get some leash plugs, some router cut out, fins right there. But when you remove that barrier, which you do have to do for a lot of ocean applications, it allows for air pockets where resin or liquid coatings can be absorbed. And liquid coatings are pretty standard for ocean applications. So that's added weight. So now you're already starting heavier, you just got even more heavier, plus resin doesn't absorb evenly. So maybe the left side of your surfboard is heavier than the right side. That's not a good surfboard. In general, mycelium has lower mechanical properties, lower flex, lower compression, so it doesn't bend as nicely. That's tensile strength. And it also doesn't compress as strong as styrofoam. And I'm talking baseline here. Let me make that clear because there have been excellent work done by researchers in mycelium to fix these. But I'm assuming we're all starting out and we all want to make some ocean stuff. So baseline, the mechanical properties aren't really there. It's also tough to shape. So if we're using a saw, if we're using a sander, you can see here at these edges, that's what we were doing. They're not too straight. So that's something that's also very critical in marine applications. Oh, I clicked on the chat. Oops. That's something that's critical in marine applications. And as you can see, this photo is actually part of the glassing process, the photo on the right. And the glassing process is in surfboards. Once you have your shaped out styrofoam, you basically put a layer of fiberglass over it. and then you put resin over it, and that's that process. It's called glassing. So this is during that. And you can see this is the same material. Look how much darker that is. It's because resin absorbed into it and made it heavier. And I actually don't like it. But when working for blue materials, what the surfboard can really show us, and I think the surfboard, I'm biased. I think the surfboard, though, is the best example for this point right here that completely different considerations need to be taken into account before you even start making your materials, before you even start doing tests or anything. You need to first figure out what your use case is and then decide your mechanical properties based on that. So you need to work backwards to make a blue material. And these are just some examples. In all of these photos, they're styrofoam. So our first one that we have on the left, we see some lettuce plants. That's hydroponics. So those are basically just raw sheets of styrofoam with little holes cut out, meant for vegetation to grow on top of a water surface. So if you wanted to make sheets like that out of mycelium, you could think, oh, what I know from that I want to make hydroponics, it's just going to be raw out there, no coating. So you're going to want to make those in their final untouched shape. Maybe you're going to want to make molds and make sure that you can pop them out cleanly. That's a nice finished surface. That's how you might go about thinking about making hydroponic sheets. These buoys, they're filled with styrofoam, mooring buoys, and they're coated with a hard plastic like HDPE, which is what you see here. So if you think, oh, I want to make a buoy, but I want to make this specific buoy that's coated in this plastic, then you better be sure that you pick a fungi species that has a high heat resistance because plastic needs high heat to form. And then in our next photo over here, this is a surfboard shaper. This is actually the brand Polyola. I have to shout them out because they use recycled styrofoam and I love them. But same with the buoys, with the surfboard, if you want to make a if you want to make a surfboard blank out of mycelium, you need to make sure that the fungi species that you use has a high heat resistance because resin has a high curing temperature. You need to make sure that whatever you're doing, if you hit a rock out in the ocean, you need to make sure that that material that you created has a low absorption so that your surfboard doesn't immediately become waterlogged and become a danger to you. So there's tons of considerations based off of your use case for how to make something out of mycelium. And we're going to go over someone really quick who does it quite well for the blue economy. So MycoBuoys is a company out of Maine. They started in 2014. They're awesome. I actually believe they're the first use case for mycelium in maritime environments. So shout out to MycoBuoys, but they make uncoated mycelium bobbers and buoys. They're still going to this day. I just saw they got a grant, I think last year. So they're doing great. But this is an excellent use case, and we are going to go over why. So, if we're looking at what they created, and this picture is a really good example from their website, they create a buoy that's perfect for aquaculture. So, lobster farming, oysters, basically a marker for where the track is. You can see there's calm water in this photo. They're not putting these buoys in very harsh environments. So, they're able to create final shape, final mold shape. They don't need to do any post modifications to their product. They already knew that before they started. Their material's okay to degrade, so it can be left uncoated. Because as you guys know, mycelium is biodegradable, so you wouldn't want to use an uncoated mycelium buoy as like a safety marker for boats because it'll degrade. And we don't know when exactly. If there's a storm, it may be faster. But if this degrades in an enclosed lobster farm, totally fine. It needs to be hydrophobic since, of course, theirs is uncoated. And different fungi species have different levels of water resistance. So they probably chose a species that is very water resistant. And then also, this is just an added thing that fun fact about buoys, a lot of people who use buoys need to be able to paint them or write on them with markers to basically identify what's below or assign a number to them. So their mold had to be something that would give them a nice flat shape and be compatible with either spray paint or markers. So they also designed this knowing that that's what their use case would be, aquaculture, the intended purpose. And then I'm not so sure, you can see it's very buoyant too, where the water level is on that. I'm not so sure if the paint that they put on that is an extra sealant, but I know that they typically don't do that. So we're going to say that they didn't. But micro buoys is an excellent example of how to design something knowing your use case and your end product. You really have to take all considerations into account when you're putting something in the ocean. So I love this chair. This is the chair I was talking about. This is from the University of Michigan, this photo. And I added this here to say, this list was off the top of my head, took 10 seconds to make the bare necessity requirements that you need to consider when you're designing a mycelium solution for ocean uses. And these are things that you wouldn't need to consider if you were designing a chair. The chair you would need to, I can't even think about the list that you would need to design a chair because I'm not a furniture designer and I'm sure that there's a lot. Ergonomics. I'm sure that that's one. But something that you wouldn't need if you were designing a sculpture or a chair, but you do need for the ocean. You need buoyancy. You need to know the water absorption rate, saltwater degradation, or freshwater, depending on what you're doing, UV degradation. You need to know what coating could potentially be on this, resin, latex, wood. You need to make sure that the fungi species that you chose and how you made it is compatible with those. And then, of course, density, which also goes back into buoyancy. So there's a lot to think about when designing for ocean solutions. And maybe that's overwhelming, but it shouldn't be. And this is the part where I hope you guys get inspired. So mycelium, even though there's a lot to consider when using it, remains to be the best alternative for sustainable blue materials. There are companies making materials out of algae. There's companies making materials out of hemp. There's so many different sustainable materials, but mycelium has all of the natural properties. It does have buoyancy. It does have natural water resistance. It has flame resistance. It has sound resistance. It degrades. It's non-toxic. If you put raw mycelium in the ocean, it can be used to clean up oil spills. It can be used to purify water. Like this material as is incredible and the best for switching out these toxic materials that are in the ocean. But how we've been thinking about creating them and going about it has been wrong. So I'm going to give you guys a little bit of a thought process. If you're thinking about, oh, I want to make a floating platform, I hope you take these words of wisdom for how I thought about going about ocean solutions and apply it to your own. So the first thing that we want to do is we're going to think back to that thing I said about we're designing our mechanical solutions based off of our final application. Pick your problem. What do you want to solve? So we're doing bulk materials, and that means that we're essentially making big blocks that have the list of mechanical properties where a ship constructor and also a buoy manufacturer would just be able to buy a block of our stuff instead of styrofoam and apply it to their application. We did this because there need to be more sustainable materials in the blue economy. So we thought that this is the best way to make a widely accessible application. But coming back to it, let's pick a couple examples. Do you want to make surfboards or do you want to make buoys? So if we want to make surfboards, off the bat, you know that's your problem. Think about a surfboard, get comfortable with it. What do I need to create? What does it have to have? It needs to be light. We have to be able to shape it. We have to be able to make sure that it can handle the temperatures of either epoxy resin, poly resin, or plant-based resin because there's different ones. Buoys, if you want to make a buoy, you have to go into it thinking, okay, whatever I make, it needs to be compatible with paint. It may need to have a higher density in case a boat hits it. It can be able to hold up better. And obviously, it needs to have good buoyancy to make sure it stays high enough above the water where you can see what marker that is. So that's number one, picking your problem and getting comfortable with it. Number two, and this is across the board with all mycelium applications, might I add, biomaterials in general, as you guys know, sustainability is expensive. Oftentimes, if you see something listed as, oh, it's sustainable, it's green, it's $50 more. Who's going to pay for that? That's not accessible. We want to create accessible solutions. So prioritizing low cost, low processing also, because the more processing you put into a product, the more environmental consequences rack up. Like higher processing means higher electricity, water usage, probably a bigger carbon footprint as well. And also environmental compatibility. So you want to get materials, of course, that are sustainable and that also meet the criteria of low cost, low processing. So I'm gonna say it. A lot of people will say, um, oh, we use agricultural waste to make our mycelium products, agricultural waste being hemp. Yes, hemp is a agricultural waste product, but hemp is $2 a pound. Hemp is expensive. Same with sawdust, same with straw. That's very expensive. Kelp is a great option, actually. But the thing is, if we're looking for environmental compatibility, kelp degrades in water. It'll often, if you do very low processing with kelp, it'll mush up and kind of just fade away. So that may not be so good if you don't want a product that degrades immediately. But you know what's awesome and free? Invasive plants. Please do not collect without a permit. I will say that. But invasive plants, you combine that with fungi species that can degrade the amount of cellulose that's in there. There's certain compatibilities in these plants and in fungi species that make them free, widely accessible, and they work really well. That's actually one of the top things that we use. We have a couple invasive plant species. Absolutely love them. We get everything for free. We're a startup. You guys, please think about building with mycelium like you're a startup, like you have very limited money. That is the best way to go about this because I'll say this too. Mycelium will grow on literally anything. People have grown it on nylon, cotton. They've grown it on, as you know, wood. I saw a picture on Reddit the other day that there was mushrooms popping out from sand on the beach. It'll grow anywhere. Invasive plants, awesome. Compost, also awesome. Prioritize low cost, low processing. It's best for the ocean. The next thing is traditional methods, like I've said, are excellent starting points, but we need to work backwards when designing for the ocean. And in the way that mycelium can and will grow on everything, you can grow mycelium in tons of different ways. You don't need to do, we mix it with grain spawn, we mix it with substrate, we put it in mold, and that's it. Anything you can think of, your wildest ideas, it can work. I I want to tell you a parable, a little story. I have a friend who is PhD. She's getting her PhD in soil science, but she is an incredible mycologist. She's wonderful. And I would tell her my ideas like, "Hey, let's grow it this way." And she'd be like, "That's not possible." And I'd be like, "Yeah, it is. Yeah, you can do that. We can do that." So there is no box for what you can do with mycelium. You can do it in any way. And these are just a couple ideas that I thought of also in like 30 seconds where I was like, yeah, if someone wanted to do this, they can totally do it this way and it would work. Ship construction. You mix grain spawn with cotton, which is super light. You can grow it inside the final casing, so the ship, so that it sticks to the sides, which would be really good to prevent water from getting in. And then you just bake the entire thing. If it's treated wood, it would be fine and that's an alternative for ship construction. Any one of you can actually steal that idea. I'm fine with it. Another one for hydroponics, you can just grow sheets of mycelium and then basically grow them halfway and then have them stick together because mycelium acts like glue. So you can just stick and grow these sheets together, bake it as one larger block. So there's more mycelium distributed on the inside because oftentimes mycelium only grows a certain distance from the oxygen source. But that's a workaround for that, and that's an example for hydroponics. Once again, someone can steal that and make that a business, and I'd be completely fine with it because we need more solutions in general. But the biggest pitfall that I see with mycelium and mycelium companies that I think is a big limitation for ocean environments is a lot of people think of mycelium as a solo concept. So we do not consider Mud Rat a mycelium company. We are a biomaterials company because a lot of people focus on mycelium and they really lock in on it. But there are so many different ways to leverage all of the unique properties that it has. And in the way of you combine it with different biomaterials, like combine mycelium with Bagasse. I'm sure that would be awesome. That's another one. Someone can steal that. I'm fine with that. Um, Enhance published protocols. As you guys know, air mycelium, or I think Myco Air, it's by Ecovative. I forgot the exact name of it. I think it's just air mycelium. But that was something that people didn't think that you could originally just isolate pure mycelium, and Ecovative did it. You can, and it's a public protocol. You can look at that and you can enhance it. You can make it, you can design it for different use cases. You can use a different species. And then another one is to use what no one else is using. So, in the way of using invasive plants, like I said, we use invasive plants and we've gotten some better results in mechanical properties in our species than we could have with hemp, that we could have if we use straw or anything like that. There's so much more to discover in using mycelium. Combine it with materials, enhance protocols, look at what no one else is doing. There have also been plenty of times where I've told experts in mycelium, like, I want to try using this material. And they say, no, that doesn't work. Like, you can't combine mycelium with this material because, like, mycelium wouldn't like to decompose it. They wouldn't like to eat it. I'd be like, just let me try. And then it works. So, nothing is off the table when you're working with fungi, which is what makes it such an incredible material. It can literally do anything. And I'm going to stop gassing it up because you guys already know. But on my final note for the presentation, since we're coming to time soon, I believe so fully that the future of mycelium and what we can do with it lies within the blue economy in the maritime industry. Not only because the maritime industry is actively looking for any solution for better biomaterials, like you can go to any companies who are somewhat affiliated with the ocean, and there is someone who wants something like this. There is a lot of terrestrial solutions for single-use plastics. There's a lot of solutions to packaging out there right now, but the most overlooked industry is the ocean industry, and that's the one that is suffering the most. So the people in there are actively looking for solutions and are very supportive of mycelium and this technology there. And then also, like I was just saying in the last slide, mycelium has all these incredible abilities and you can make it in so many different ways. If you look at everything that mycelium has done so far in research, it's just the tip of the iceberg. And I promise that any one of you can go and just try some idea that someone said may not work, or just try to grow it on some other material that someone's like, oh no, and it will probably work and it will give you a new solution to some type of problem. So I believe that that's the direction that mycelium is going in. And I hope that some of you guys listening here today are inspired to help the ocean industry. But before we get into questions, I just want to thank you all for being here. I had a wonderful time talking about this. If you can't tell, I absolutely love the blue economy and where mycelium's going in it. So if anyone would like to chat after this, emails open. I love to talk. Also, the Biodesign Challenge in combination with Open Fung, they're putting together their massive, awesome program right now, the MycoStack Challenge, which will basically create a public knowledge repository for mycelium. And I've mentioned it a couple times, but if you guys are interested in learning more, I know they put their links in the chat. And that totally would have saved me like a full year of research if we had something like this. And it's all pretty similar information. Actually, there's a lot of really cool stuff in there. But get into it. Mycelium's small but rapidly expanding. If you guys want to be cool and join before everyone else joins, then you should get in on this. But thank you, and I'm happy to answer any questions.
Thank you so much, Amelia. That was really wonderful and incredibly edifying. We have some questions coming in through the Q&A portal. I encourage everyone with a question in mind, uh, write it down there, and then I will field them and ask Amelia. Um, I guess I'll answer one question for you. What is the name of your startup? Could you please repeat it? Uh, Mudrat. It's really fantastic. I'll put the link to that also in the chat so you can get directly to their website, learn a little bit more about their mission and their activities. Um, we have a question here. How do you engineer mycelium to be lightweight yet strong enough to withstand repeated wave impacts? And can its mechanical properties be tuned through growth conditions to replace petroleum-based foam in surfboards without compromising strength, buoyancy, durability, or long-term performance in seawater?
Okay. So I'm gonna do this one at a time because I'm pretty horrible with remembering two questions at the same time. But with the wave impact, a lot of times in ocean applications, you're going to be coating whatever foam you're putting in the ocean with some type of protective barrier. So that would either be the resin, latex, wood. And with that, if you put mycelium into the ocean with its coating on, it should last indefinitely because that's also an added layer of structural integrity and strength that you get from that coating. But if you put mycelium, like if we think of myco buoys, just out into the ocean, it will degrade at a certain point with those harsh waves, harsh conditions. So it really is just a lot of, I would say we need more data to figure out exactly what type of conditions would break it down because you could also use some stronger species like reishi mushrooms are a bracket mushroom. They have different skeletal structure than oyster mushrooms and they're a lot more tough. So if you use a species like that, you put it out into the waves, it would probably last longer than an oyster mushroom. That's just off the top of my head. And then so it really depends, I guess, on the mix and recipe that you're using for how well it will hold up in the waves. And then the next one, tuning. Would you remind me, please?
Yes. Let's see. Strength, buoyancy, durability, or long-term performance in water. Yeah, that's just it. Tuning mechanical properties through growth conditions.
Oh, yes. That is absolutely something that you can do. So, if we think about Ecovative and their air mycelium, where they're able to isolate just pure mycelium as opposed to substrate plus mycelium, it could be the exact same mushroom species. You get completely different end results with that. And also, mycelium is very fragile in how you grow it. So if you change the environmental conditions of the CO2 level, which Ecovative, they got their pure mycelium by raising that CO2 level really high. If you change the temperature, if you let it grow slower, even down to how you like bake it, you can freeze dry it. You don't need to essentially dehydrate it or slow dry it. There's different ways of drying, there's different ways of growing, and in every factor that you're using to make this product, you will get a different end product. So, very important when you do mycelium experiments to write down all of the basically everything you're inflicting on it. Like I did this temperature, this humidity, this and that. Because if you do another round and any of those factors change a bit, then you could get a different outcome.
Great. We have another question. Are you interested in using other materials than resin or fiberglass for the glassing process in surfboard construction?
Yeah, so we actually are not making the end product surfboards. We're just making the insides. And we're doing that so that anyone who does make surfboards can have a new material to replace with their EPS, their styrofoam blanks. So we're not actually the ones putting that glassing on. But in the movement of sustainability in the surf industry, a big thing is we're a lot further along with eco-friendly resins. So plant-based resins and also replacing the fiberglass with a hemp cloth is one. So there's more solutions in the glassing process right now than there are in the blank process, so the core process, and that's what we are trying to solve.
Let's see.
I saw one about invasive plants in the chat
Yes.
that I'm excited about.
I'll read that. As a pathologist, we should state that invasive plants are high-risk raw materials. These need to be handled carefully as the collection and distribution could potentially be illegal. Knotweed and riparian areas in the UK cannot be moved without a permit. However, we do applaud their use with care and ask if you have tried material recipes under the law of the limiting nutrient to improve the resulting mycelium properties. Thank you.
So I saw that roll by and I wanted to like make sure there was time for that because it is very important that you don't just go and move. You need to really understand the invasive plant that you are using, from one pathologist to another. So we do have a permit to go and collect this specific species, and we have full protocols of how to collect and transport. And then if we aren't using the full plant, how to basically destroy it to make sure that it doesn't spread or leave our facility. So you need to be very careful when using invasive plants, but if you have a permit, if you have a plan and you talk to your local municipalities, they're an incredible resource to be able to use. And these organizations want people to come up with ways to remove them. And on using invasive plants for limiting nutrients for mycelium, that's actually something I haven't thought of. So that's an excellent idea. What we've been doing so far with it is we have a couple new methods that we're looking to do that kind of deviate from the grain spawn plus substrate bake it method. And in that, the plants that we're using are kind of adding as like these suspended matrix layers. So we're using them for more structural growing mycelium than nutrients, but that's very interesting. And if we don't research it, then I think someone else, that would be awesome.
Um, okay. I had a question. Could you perhaps share some insights on fungal strains that you think are particularly well suited for use in marine environments? What sort of experiments have you tried and found really promising? What did you write off because it wasn't working out as well as you imagined?
Yeah, so we've tried the whole actually I think we've only tried a few species, but lion's mane we don't like that much. It gave some promising results for like small scale block tests and everything, but we don't like lion's mane. It's really between blue oyster mushroom and red reishi for us in what we do. So blue oyster mushroom, we do all of our preliminary experiments using that because it is the friendliest, it grows the fastest, and it's very aggressive. So since we're putting this in, we're combining it with plants that we may not know like the plant's nutrients too well because it's just a random weed or something, then we'll throw it with an oyster mushroom and see what that can do. Oyster mushroom, it's pretty buoyant too. It's squishier than a reishi mushroom because it does have that different skeletal structure. So we start everything with oyster mushroom just to basically validate, like, okay, can we grow it in this shape, in this way, doing this? And then we'll move on to reishi because reishi's stronger. It'll give you this really dense, hard item which is very good for the ocean, actually. So if all of our designs pass the oyster mushroom phase, then we move it to the reishi mushroom phase, and then we basically see, does our reishi like to eat this type of plant? Can we grow it in this way? But it's really those two that we absolutely love, and we totally recommend that anyone starting use oyster mushroom because, like I said, super easy. It's very friendly. Oyster mushroom, we love it.
That's amazing. Let's see. Have you tried growing internal structures known to be lightweight but strong, like patterning inside bird bones or honeycomb shapes?
Ooh. So honeycomb shapes? Yes. There is actually an experiment that we do that we are excited about, and it's creating this internal matrix layer out of a different biomaterial that we're developing that I can't say too much on. But honeycomb structure is the strongest, so surfboard blank it's excellent for that because it also has really good weight distribution. So there's actually a company that I put in the slide. It looked like someone was holding it up on the sustainable certification slide. That company is called Swell Cycle, and they 3D print surfboards using that honeycomb shape because it's good for weight distribution. So yes, we do like to use those shapes. We love a honeycomb to put on the inside. And really, our big thing is just making sure that any material that we're making is uniform, since it's going to be shaped into all different types of things at the end. For lightweight on the inside, we want to make our entire material a uniform lightweight. I think that's a super good idea to kind of mix and match. Like maybe you have a tougher internal structure or skeleton and you put mycelium on the outside, but you can achieve that lightweight by using different growing methods, like we mentioned earlier, which is something that we're trying to do. We're using the internal skeleton as more of a structural and weight distribution thing.
That's fantastic. I think that's all the time that we have for today. I want to highlight once again that next week, OpenFung is facilitating a webinar as part of the MycoStack Micro Challenge on the future of mycelium education. I'm putting the link to that right now in the chat. The link will allow you to register, just as with this webinar. Registration is free, and we will do our best to make it online in a timely fashion after the fact. I want to thank you again, Amelia, for joining us today and sharing all the amazing insights you have on mycelium for marine environments and the work that you're doing at Mudrat. I've put the link in the chat, but if you could perhaps share email, socials, wherever we could reach you.
Yes, so I will type it in the chat also, but you can find us Mud Rat Surf. So our business name, it's Mudrat, MUD space RUT, but our website is mudratsurf.com. We also have an Instagram, which we love, which is also just Mudrat Surf on Instagram. Like I said, me and my teammates absolutely love talking to people. So my email is amelia@mudratsurf.com. And there's also different parts on our website where you can put in your email information, send us a message. You can email me directly, but Mudrat Surf, and you will find everything about us.
Amazing. All right. Well, thank you everyone for joining us today. We look forward to seeing you next week, and we look forward to following along with the development of Mudrat. Thank you so much, Amelia.
Thank you.